Now, for this first one on the left, I'm going to do this one just a little bit different than perhaps what you may be expecting right now. Some of you know this trick, and it only works as long as there's no other operations here on with the parentheses side, okay? And it could be on the right, it doesn't matter. But if I get a set of parentheses like this, and I not only see that the number's low that I'm distributing, but that the other number on the other side of the equation or inequality is a multiple of that number, I like to just go in there and just divide both sides by 3. Well, what the crap are you saying we can just divide by 3? It's a principle of equality. You can do it anytime you want. What does that do? It gives us a phantom 1 right there. Okay, so what am I left with? Well, it leaves me with the 5x minus 4. You can put it in parentheses if you want. Like, if that makes you feel better, feel free to do that. But then I get this is less than or equal to, instead of a large number like 24, now I've kind of narrowed that down into 8. Okay, now you'll get the same answer even if you did distribution, okay? So if you're like, I distributed, and that's the way I like it, do it. It's not going to affect the answer in the end, okay? But now, what this does for me, it allows me to deal with some smaller numbers, right? So I would say, let's go ahead and add 4 to both sides. Zero that out, so I got 5x, and then I dropped is less than or equal to now 12. And then divide both sides by 5. Okay, now again, some of you knew this already. Some of you didn't, and maybe still hate it. I don't know. You don't have to use it, but it is a method that you can use, okay? So in whatever you did, you should have still have gotten x is less than or equal to 12/5. That's what you should have got, okay? So if you use distribution, you would have had the same answer. It's just, let's see, it would have been 20 15ths or something like that. You just got to simplify it, whatever it was, okay? But that does solve that one. So let's go now to the right. And, well, no tricks here or shortcuts. Again, I'm going to put the x's on the right, though, and then the numbers on the left, because again, doing this is going to force that coefficient to be a positive. But you don't have to do it like that. All right, so x's on the right, numbers on the left means that negative 5x has to be zeroed out, so add 5x's, excuse me, to both sides. So that does zero that out, just like we wanted. And then we're left with the 12x's there on the right. But now that plus 11, it has to be zeroed out as well, so minus 11 on both sides. 5 minus 11, that'd be negative 6. So negative 6 is less than 12x. Divide both sides by the coefficient 12, and now I end with phantom 1x. Well, comparing this with, looks like negative 1/2. So negative 1/2 is less than x. Now this is an and statement, right? So let's look and see what this ends up looking like on the graph, okay? And then we'll figure out the interval. But right in the middle here, we got a 0. I'm going to put 12/5 way over here on the right because it's positive. And then negative 1/2, again, it doesn't have to be, when you're doing this by hand, it doesn't have to be proportional. But something like this, right? So my 12/5, I'll do this one in red. It's a closed circle because it actually does equal to 12/5. It's not eating the x, so I'm going to shorten this line to the left, which is kind of on purpose, which hopefully we'll see here in a second. And then the 1/2, negative 1/2, open circle, but this one's eating the x, so this line goes to the right. Now you could extend these. You could say, well, I know then that the red line would go all the way essentially to the purple line, or the purple circle, and then the purple one would just go all the way to the red, because we're looking for an and statement. This is the only area where it would make both inequalities true. Anything on the outside, right, according to the graph, anything to the left of negative 1/2, false, including negative 1/2. And anything to the right of 12/5 would also give us a false statement. So that's the graph. And again, when you put this in on canvas, you're going to have the open circle, just one line, and then the closed circle right there. All right, so on this next part, so I got the graph in green, but neither one of those inequalities is going to work. And you could say, well, couldn't we just put an and statement between them? No, well, this is where we need that compound inequality, right? So we're looking at an x value. See how it's sandwiched between this I guess, negative 1/2 right there. And then also the 12/5 here on the right. So you see that it needs to be greater than the negative 1/2, but also it needs to be less than or equal to the 12/5. Why is it, how do we know it's less than or equal to? Because it's a closed circle at 12/5. And why is it just greater than or why is negative 1/2 less than the x? It's because we know it's an open circle right there from the graph. Okay, so that's the actual inequality that we would need for a problem like this one. And then the interval, pretty much the same kind of thing, starting at -1/2, that's where the interval would start. It's not included, and then it would go all the way to 12/5. Sorry, different color. 12/5, which is included, so we get a square bracket like this.